Let's talk about linear inequalities and absolute value inequalities. I'll start with linear inequalities. I have an example here on the screen already. The reason it's a linear inequality is because the biggest exponent you see on x, even after you distribute, is going to be 1. There's no x squared, there's no x cubed, there's no square root of x, there's no division by x. It's just x to the first, essentially. So that's what makes it linear inequality. The inequality part means I have, instead of an equal sign in the middle here, I have a less than symbol. You could also have a or a greater than, whichever way you want to think about it. If I'm going left to right, then this is a greater than symbol. But I could have a greater than or equal to, or a less than or equal to, and that would still be an inequality. So first thing I'm going to do is distribute. So I have negative 5x plus 5 plus 3 is greater than. I can combine like terms on this side, so I have 3x minus 4x. That's a negative x minus 4. I can combine like terms on the left-hand side, so I have minus 5x plus 8 is greater than negative x minus 4. We're much better at figuring out zeros of things as opposed to some other numbers, so I'm going to shuffle everything to one side of the equation, and by equation I mean inequality. But you can choose which side. I'm going to go to the right-hand side because I like positive leading coefficients, so I'm going to move everything to the right, so there's just going to be a 0 on the left. If I add 5x to both sides, I have a negative x plus 5x, that's 4x. And then subtract 8 from both sides, I get a minus 4 minus 8, that's a minus 12. So I have 0 is greater than 4x minus 12, which is equivalent to my original question. So if I can solve this, then I'll find the solutions to the original. Well, like I said, we're a little better at finding when things are 0, so let's change to the actual equation. 0 is equal to 4x minus 12. If I then add 12 to both sides of that equation, I get 12 is equal to 4x, divide both sides by 4, and I get x is equal to 3. What that means is x is equal to 3 is a possible tipping point of this equation. It could change from positive to negative there. To figure that out, we'll build ourselves a number line. And the only place that it could change signs is at 3. So I'm going to pick my favorite number to the left of 3. Let's go with x is equal to 0. Pick any number to the left of 3. And I just want to figure out whether 4x minus 12 is positive or negative there. So if I plug in x equals 0, I get 4 times 0, that's 0. Minus 12, that's a negative 12. So over here, 4x minus 12 is negative. To the right-hand side, pick your favorite number. To the right of 3, I'll go with x is equal to 5. Plug it in here. So for x is equal to 5, I'm going to get 4 times 5. That's 20. Minus 12. I think that's 8, but I'm pretty sure it's positive at least, so I'm positive over here. So I know to the right of 3 it's positive, and to the left of 3 it's negative. And if you look back, I wanted when 0 was greater than 4x minus 12. So that means I wanted 4x minus 12 to be negative. I'm interested in these. So that means my solution is going to be everything to the left of 3. So negative infinity up to 3. And since this was a strict inequality, I do not get to include 3. So that's going to be an open bracket or open parentheses till 3. Okay? You could also think of it as visually graphing, kind of comparing what 0 is greater than 4x minus 12. So if you think of the graph of 4x minus 12, it's a slope 4, which is positive, intercept negative 12. So give or take, it's going to look a little something like this. And it hits y equals 0 right at x is equal to 3, which is what we had figured out in this line here. Well, I wanted when that was negative, which means I want when is the graph below the x-axis. Well, that's over here. Those are all the x values from negative infinity up to 3. So that's visually how you can tell what the solution to that is too. So that was an example of a linear inequality. An absolute value inequality, let's do one of those. And the example I'm going to go with is, let's solve. How about the absolute value of x minus 4 plus 1 is greater than or equal to 10. What you want to do first on these is to isolate the absolute value, so that plus 1 is kind of in my way. So let's subtract 1 from both sides. So the absolute value of x minus 4 is greater than or equal to 10 minus 1, which is 9. So I want to know when is x minus 4 greater than or equal to 9. Well, one of those possibilities is x minus 4 is greater than or equal to 9. Like if you got, say, 10, 15, 42, any of those values inside here, that would mean the absolute value of it is bigger than 9. But it also would work if you had x minus 4 was less than or equal to negative 9. For example, if you got a negative 10 in here, the absolute value of negative 10 is positive 10. That's bigger than or equal to 9, so I'd want those two. So it's kind of like you're looking for the numbers to the right of 9 and to the left of negative 9. So that's how I get to these two. And then these are regular linear inequalities. We already know how to do those. So on this left here, I'm going to essentially add 4 to both sides. So negative 9 plus 4 gives me a negative 5. And over here, I have 9 plus 4, that's 13. Just keep in mind too, I didn't mention it above, anytime you multiply or divide by a negative number, you want to switch the signs of these inequalities. That didn't happen in either of these two examples. So I didn't have to flip any of these, which means, so here's my solution. It's both of these two. If you write that in interval notation, that's going to look like, well, to the left of negative 5 is a negative infinity to negative 5, and it's a less than or equal to, so I get to include it, so hard bracket, and then union, which means also from 13 on, and I get to include 13. So that's what it looks like in interval form.